Alright, today we're going to be talking about exponential growth and decay equations. Now note, this is different from the functions that we looked at yesterday. We're not going to be doing any graphing, rather we're going to be solving, most likely using word problems. So there are two types of exponential growth and decay functions. One, obviously, is the growth function, and one is the decay function. The equations are going to look really similar, but they have one key difference, which we will get to in a minute. But first, let's start with the exponential growth. So our equation is going to look like this. Y equals A times 1 plus R raised to the t power. Now let's talk about the components of this equation. The first thing is A. And A is going to be the initial amount. So the amount of whatever it is that you're calculating, the amount that you're starting with. Next we have R, which is your rate of change. And it's important that your rate of change in this formula is expressed as a decimal. Oftentimes, if you have a word problem, it'll be given to you in percent form, but you will need to convert it to a decimal to use this equation. Lastly, we have t, which represents time, so the amount of time over which your scenario is occurring. Now, for the decay equation, it's going to be very similar. We have y equals a times 1 minus r raised to the t power. So instead of adding the rate of change, we are now subtracting it. So let's go ahead and label these parts too. A, again, is still going to be your initial amount. R is your rate of change. And again, this is going to be expressed as a decimal, but when you're dealing with decay, your rate cannot be greater than 1, whereas over in exponential growth, it is possible that it's going to be more than 1 as long as it is more than 0. And then once again, t represents time. Now let's look at some examples of word problems that involve exponential growth and decay equations. So for our first example, we have the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. How much will the gift card be worth if no one wins after 10 days? So we first need to start off by writing our equation. The fact that the amount of the gift card is increasing should tell us that this is going to be an exponential growth problem. So we'll be using the first equation, y equals a times 1 plus r raised to the power of t. So let's go through and determine what we need to put for a, r, and t. If you read the problem, it says that the contest is beginning with a $100 gift card. So the fact that it begins with that amount should tell us that 100 is going to be our A. If nobody wins, or if nobody calls to claim their prize, then it's going to increase by 2.5%. Now remember what I said when we were labeling the equations. Typically, you'll be given the rate of change in a percent, and you need to put it in a decimal. So this should tell us that our rate of change, or R, is going to be 2.5%. And then lastly, the question is asking us how much the card will be worth after 10 days. So 10 days is the time frame that we are working with this problem. So that is going to be t. So let's plug all of that into our equation. We have y equals, and then we decided that a is 100 times 1 plus r. If our rate of change is 2.5%, then written as a decimal, that is going to be 0.025. And then t is 10. So now that we've filled in all of our variables, we can go ahead and solve. This is going to work the same way as order of operations. So the first thing that we want to do is handle what's in the parentheses. We're going to add 1 and 0.025 together, giving us 1.025. Then we're going to handle the exponent. Notice the exponent is only applied to what's in the parentheses. So you're probably going to have to type this into your calculator, but the value that you would get when you raise 1.025 to the 10th power is going to be 1.28, and we will round that to 2 decimal places. And then finally, we're going to multiply 100 times 1.28, which we get 128. So after 10 days, the gift card will be worth $128. Now let's look at an example of where we would need to use the exponential decay equation. The population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% per year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. If the trend continues, predict the population in 2010. So let's go ahead and label all of the parts of our equation. It first tells us the rate, and it's an average rate of 0.3% per year that is going down. So 0.3% is going to be R, but remember we want to have this in decimal form, and while I know that this is in decimal form, it's still a percent, so we want to make that into a decimal without the percent, so 0.3% is going to be 0.003 in decimal form. It then tells us that the initial population of the county was 88,647 people. So because this was the initial amount, that is what we're starting with. A is going to be equal to 88,647. And lastly, it doesn't explicitly tell us the time, but it does say that we're measuring from 2000 to 2010. So we know that T is going to be 10 years. So let's go ahead and plug everything in. We have Y is equal to our initial amount, 88,647, times 1 minus 0.003, which was our rate of change, raised to the 10th power. So again, we're going to follow the order of operations here and deal with the parentheses first. When we subtract 0.003 from 1, we get 0.997. Now we want to raise 0.997 to the 10th power, and remember that that 10th power is only covering what's going in the parentheses. So when you put this in your calculator, you're going to get 0.97, and we can go ahead and round to 2 decimal places. And then lastly, we want to multiply our initial amount, which was 88,647, by 0.97, and that is going to give us 88,381, and we will round it to a whole number because we're talking about people. So in 2010, we can expect that our population will be approximately 88,381 people.